Hi, in this video, I'm going to talk about PyTorch notebooks and how you can work with images in PyTorch. So usually we have to convert images back and forth using PyTorch Tensors and PIL images. And if not, you need to use different helper functions from here and there, and you need to import them, and it's quite tedious. So it seems like all these things code looks like boilerplate. Basically, we should not need to do that. So that's why I'm starting a new project called ImiTools. So basically it will wrap everything into a single place. So basically here we have a wrapper. So basically we can feed images from the internet, disk, PIL images or PyTorch tensors, and then you can bring them into a single place. You can resize, crop, normalize, and pick some individual images. And after that, you can output them in various ways. Like you can show them to the screen and you can send to disk. You can export them as PyTorch tensors or PIL images, as well as you can encode them as a simple video, and it will be really nice in some case. And all these things can be done using a simple one-liners like this. You can download and crop, and you can normalize, and it will be really easy to use. And let me show you how you can do all these things in this video. So now you're looking at the tutorial notebook, and check the description below on how you can get that, or you can go to the GitHub repository over here. You can get access to this notebook from here. Right, now since we have the notebook, let's go through that and let's see how we can work this. Right, and first go to edit, and I'm gonna like clear all output so we can start fresh. And first we need to connect into a notebook runtime. So here we're using Colab. Basically I can set chain runtime type, and I'm gonna hit the GPU. And the reason why I'm using GPU, we are working with videos, so in that case we need to have a GPU. That's the only reason, I guess. And then if you use some other service, things will be something similar. Now we're trying to install that, so basically you can grab it from the GitHub and simply install that. Right, so we're done over here, and then I'm going to import this as import ImiTools as I. Right, and there are some other useful imports that I have to do. Torch, PyTorch, of course, and math and time. It will be handy in some cases. All right, now let's do simple hello world. So basically I'm going to grab some images from the URLs over here, and I'm gonna hit I. So all the things will be happening with this I global import that we did, I.download, and URLs that we have over here, and crop it by 256 and show it. Right, and let's see. Right, so we have very nice looking cats. Okay, we are good to go. So I'm not working with cats right now. I'm gonna create some like fake images. So basically here I create some PyTorch tensor. So we have random images. We have 10 images, and we have the 3 channels RGB and B, and we have 8x8 pixels. So basically it's a very tiny picture, and I'm gonna enter that. And so basically we have some sort of tensors. Right now I need to see how this looks like. So that's why we have this wrap function. So basically I can wrap any kind of thing. So here I'm gonna wrap a PyTorch tensor, and then I'm gonna simply say show. Right, so basically we can see, yeah, something like this, and quite nice. All right, and of course you can change the calls count and the scale. I can run this. So basically I'm gonna set calls 2 and the scale is 1. I can set the scale to maybe 3 over here. Right, so basically you can change them as you like. Right, so basically here we have a concept called wrapping. So basically we need to get various images into wrapper, and we're going to use this i.wrap function for that one. So you can actually import any sort of things into this wrapper. You can put a wrapper itself, you can put a PyTorch tensor, and you can set up PIL images. So let's give it a try. So I'm gonna set my PyTorch tensor again. I'm gonna see that. Okay, that looks nice. I'm gonna convert them into some sort of PIL images. So here basically I need to type this .pil at the end. So I have a set of PIL images. So if your library is working with PIL images, so of course you can work on this. And let's imagine you have completed all your tasks, and then you can wrap them back into a wrapper. So you have PIL images over here, and you can see them again as well. Right, and of course you can convert this back into a set of PyTorch tensors at the end if you like. And of course you can simply wrap a single image as well. So that's totally possible. So you can even do a PyTorch tensor as well here, just a single tensor with 3 dimensions. So you can do that as well. Right, now let's try to do some resizing. Right, as you already know, our image is quite small, 8x8 pixels. So but we need to increase that into maybe like 256, and here's how we're gonna do that. So we're gonna wrap these PIL images, and I'm gonna resize them into 256, and I can show them. Let's see how it looks like. Right here, we are invoking some resize function of the PL library. And the reason is default resizing algorithm is bilinear and sampling algorithm. And so you need to change that into something like nearest neighbor. So that then it will be looks nice in our case. But by default, bilinear is just normally totally fine. So in this case, we need to set it to nearest sampling. So the value is 0. And I'm going to set the resample to 0. So then it will looks like what we really need is something like this. And I want to mention that you don't need to use this all the time. Just simply using the default value is almost fine. So of course you can, here I set some PL images, but you can also set tensors as well. You can simply directly grab some tensors and you can resize them as well. And you can actually resize in different resolution as well. Like here, this is 256 by 256, but of course you can do any value like here, like this 256 by 128. Another functionality is actually cropping your images. So let's give it a try. So I can download some images from the internet and it will look something like this. So basically it has different sizes and then I need to crop them into a single resolution. So here actually it's not exactly cropping, it's a resize and crop functionality. So I'm doing a 256 by 256 resize and a crop, and it will looks like this. Alright, and then here we are doing some middle cropping, and of course you can do a top cropping, top portion of your image or a bottom portion of your image. So there's a warning over here. I'm going to close it right now. That's totally fine. Right, another thing about our wrapper is it's immutable wrapper. So basically all the steps that you do, the step are immutable. So basically you can have a checkpoint like this. So here I'm doing like resize of 256 and also another checkpoint for 256 by 100. So there are two different resolution. I have two checkpoints of the same set of image, and then I can show them like this individually. Right. Okay. Also, you can show them in the single line as well. That's also possible. Right. So basically, we have immutable functionality, and this will be really handy if you're working with large projects. You can create a variable with all the settings and you can continue work on this. And that's what we are trying to do it over here. So basically we're gonna wrap our PT images PyTorch tensors, and then we can resize them, and then we gonna assign them into a single variable called images like this. I'm gonna write again so we can see them again one more time. Right, then I'm gonna use some other functionality in this tutorial. So we're going to use this images checkpoint all over the place. Another functionality that we need to work with merge different images. So here we have a very interesting merge function. So basically you can merge almost anything. So here we have wrapper. You can download from internet, and you have a set of PyTorch tensors, and then we have PIL arrays, and we have single PIL image and also single PyTorch tensor. And basically we can merge all those things together and create a single wrapper, and like this. So I don't think you have to do something like this in a practical project, but I'm going to show you the possibility that you can use any amount, any types of images. It's just going to work. And another thing is picking some individual images. So here I'm going to download some images from the internet again, same cat images. Right, then let's say I need to pick only the second index one. So basically last one. So I can do it like this. And then let's say I need to pick multiple of them. Of course, I can simply add them like this. Also, you can pass an array of indexes as well. So basically, if you are using some other library, or maybe you are running inside a loop, and you can use this. All right, now let's get back to like saving and loading images from the disk. All right, let me open this folder directory. All right, now we can see things over here. Now you can see there's nothing over here. So basically there are two directories. I'm going to save my images. This is the checkpoint that we already have. I'm going to to dir. I'm going to put them into a directory called my images like this. Right. And then I'm going to reload this like directory index, and I can see that my images, I can go inside. So basically I have these 10 images over here. I can load them over here. I can see them. Right. Nice. And then, so you can see here we have prefix. I can change the prefix, like here we have image. I can set it to something like my image. So it's over here. Like, so here we have directory called my images that we already created a few seconds ago. And then I can get images from dir like this and show them like this. And of course, if you like, you can simply convert them into a PyTorch tensors as well. Simply you have to put PT, not the show actually, like this. Now you have a PyTorch tensors like this, and I can do shape, and yep, you can see how it looks like. And of course, you have another function for prompt path that you can pinpoint an exact image in your disk. You can load them as well, like this one. All right, now it's time to search the internet. Right, basically this is the fun part. So if you're working with some projects, you need to bring some images, and the ideal place is the internet. You can search the internet and get them. So of course you can manually do that, but it's tedious, but we have a very interesting way to do that. So basically we're gonna search the DuckDuckGo search engine, and we're gonna pick some images from there. We can pick some URLs from there, and we're gonna use our download tool to download those images and do anything you like. First, I'm gonna install this DuckDuckGo_search library. Okay, I think I already done that. And then I create a simple function. Basically, it will simply give me the URL. Right then, I'm gonna simply type search images, cats and dogs. I can see a set of URLs like this. So I'm gonna feed these URLs into our download function like this. I'm gonna crop 256 and show them, and simply it's just gonna work. Right, now you can see it's how powerful this is, and I can simply type anything I like. Simply like you are searching on DuckDuckGo. Say unicorns, and it's simply gonna work. So I can set the number of images that I want. Here I can say, I think max images. Let's say like we can put something like 20. So by default it's like 10, I guess. Yeah, we can put the value like. So basically it's not max images, it will be max results. Sorry. So it will simply bring those images from the internet. And so here we say max results. The reason is we are not sure 100% that each and every URL would work. In this case, it worked, but some scenario it won't work like that, right? So that's about it. All right. Other thing is PyTorch device. You can set a default device to ImiTools. So basically, when you're exporting into PyTorch, it will automatically convert those tensors into that device. So you don't need to convert it all the time. It will be really handy tool sometimes. So basically here I set the device to CPU. Let's change it back to CUDA, and then I'm gonna type, and I'm gonna convert those images into PyTorch tensors, and then yeah, we know it's CUDA like this. Now I'm gonna try to create a video out of my images. So that's is really neat. So in order to do that, you need to have a GPU runtime in your project. So that's why we created GPU runtime. So make sure if you're using some other place, some other notebook environment, make sure you have a GPU. And then you need to have ffmpeg installed. Fortunately with Colab, it's already there. You don't need to do anything. You can type this command to see that. In case if you don't have this ffmpeg command, you can install that using this code. So basically uncomment this and run it. It will install ffmpeg, and it will take some time. Right, and then converting it to image is quite easy. So basically you have to say images to video and show, and it will create a instant video like this. So basically you can play it inline like this, and quite handy. And you can see the frame rate as well. By default, I think it's frame rate about 12 frames per second. So basically it will bring 12 images and set them into a single second. Here I can set to 1. So basically create a video like here we have 10 images in this wrapper, I guess. So I can create a video of 10 seconds like this, right? It's really handy. All right, let me show you another very interesting functionality of ImiTools. It's called live plots. If you're training a model as experiment, of course, and then you need to see how it looks like. And sometimes you need to wait 10 minutes or maybe more than that. You don't know what's happening there. And this is a nice way you can see what's going on here. So let's imagine you have generated some images and do some interesting thing and create a loss function and try to see how it's gonna work. And then now you need to see intermediate images and how they look like. And here we have functionality. So you can create a live plot like this. This is our global handler, i.lightplots, and I have one column. So one column of data. And let's say we have a for loop over there and we are iterating through, and I have a fake delay over here. So I'm going to show the output of images, the images that we generated every 10th time. So it's pretty easy. I have to say lp.im show. So this is go with the pyplot syntax. It's not exactly pyplot, so but you can see the syntax. So the index is the column that we are going to work with. We already have one column, 0th index, and the image that we want to see, and I'm going to say update, and it will really important like LP close at the end, otherwise you have some duplicate images. All right, let's try to run this. So you can see it will change like this, right? So you can basically see what's happening inside your loop. And of course you can plot things. Here this is another example. Again, I have a loss function. So basically it's a simple sine loss function. If we have some loss, I'm gonna append this loss into array, and then I can simply plot them like this. Here I created like 2 columns. So one is the first one is the image, and the other one is this plot like this. I'm gonna update this. Let's run this. So we have this image over here, and we can see the loss function over here. So our losses, yeah, it's interesting. And then of course you can have multiple plots as well. So you have this, okay. And then again you can have multiple plots, and you can assign some colors. So basically here we simply use the pyplot syntax. So basically exactly we're using pyplot syntax. You can simply use that, and also I can simply write this, and yep, and now we can see like this. All right, this is it, and I think I covered a lot of things. So basically we start with simple hello world. So basically we learn about how to bring data into the our wrapper, and we do a lot of conversion like cropping, picking, normalizing. We haven't done normalized, but it's quite simple. And then we can export into different various formats, and yeah, it's interesting. Right now you can use this, and it's quite stable, but we're gonna make it much better in the coming days, and we're gonna add some more features like applying mapping and something like that. And check our repository, and yeah, and I think this will be helpful. All right, I'll see you soon with something interesting. Bye.